Let's take a look here at 2.2. We're still dealing with proportions here, except we're going to take a look at the word problems. So we're going to start here with number 1, which we want to create a proportion. So that's the first thing we want to do is know that we're going to create a proportion. The question is, what does our proportion look like? So Miss Thompson has an algebra class, and they get their test back. 40% of them got a B on the test. So 40% is 40 out of 100. Okay, and so when I look at this, what I'm putting on top is the part, and what I'm putting on the bottom is the whole. Okay, and so if I think of the ratio as a part divided by a whole, that's what I've got. I've got the part of the percentage, and then the total percentage, so 100%. So 40 out of 100. Then if 80 students received a B, how many students took the test? So my part is 80. I had 80 students that got the B, and I want to know how many of them took the test. What's the whole number of students that took the test? Okay, so there's my proportion. So now I'm just going to need to solve this. So I've got 40 times x and 100 times 80. So this is 40x is equal to 8 times 100 is 800. So 80 times 100 is 8,000 divided by 40. Then a 0 is going to cancel out with a 0, and I get 800 divided by 4, which is 200. So 200 students, don't forget to label, students took the test on this word problem. So 200 students that took the test, 80 of them received a B, which is 40%. And you can do check 40% of 200 to be 80, but we don't have to because we know we set it up right. This one, number 2, is similar to what we had before. So we have a small triangle. We're in the small triangle. We have a side, lower side, the bottom, I will call it, of 4. And then lower side, the bottom, I will call it, of the bigger triangle is x. So I'm going to compare 4 over x. So this is the small triangle to the larger one. And so small triangle to the larger one. Then I've got this side over here, which looks like it might be a hypotenuse, but doesn't necessarily say these are right triangles, but it's a longer side. So that longer side in comparison here. The small triangle is on top, so that's 5 over 10. So now I've got cross multiplying here, 40, 4 times 10, and 5 times x, divided by 5, and x is equal to 8. Notice that I did 4 times 10 to get 40 right away. You could have that step in there. 4 times 10 equals 5 times x, if that makes you feel more comfortable. But when we're multiplying just numbers, we don't have to deal quite as much with that. Number 3, Susie is 5 feet tall with a shadow of 11 feet. So here's Susie. Susie with some nice long hair. Susie, she's got a shadow over here that's 11 feet long, and she is 5 feet tall. She's standing next to a tree. So here's a tree. She's standing next to a tree with a shadow that is 37 feet long. We want to know how tall is the tree. Okay. So now when I do my proportion here, when I set up my proportion, I'm going to set it up so that I'm looking at height compared to height and shadow compared to shadow. And I can either compare them within the same fraction, or I can put all the heights on the top and all the shadows on the bottom. Okay, and I'm going to do this the opposite of what we did in the last one. So we went from small triangle to big triangle within a fraction. Let's go the other way this time. So I'm going to do Susie's height divided by her shadow. And then I'm going to do the tree's height divided by its shadow. So I've got height over shadow here. And so then I'm going to cross multiply. So I've got 11x is equal to 5 times 37. And again, you could do the 5 times 37, and that'd be fine. And if we multiply that out, 11x is equal to 185. And divide by 11 on both sides. I'm going to run out of room here, but you can, hopefully you had enough room as you're writing this. I made my tree apparently too big. 185 divided by 11 is 16.818181. So I want to round that 16.82. So label on this one is feet. So 16.82 feet, that's how tall the tree is. And so now we set this up, we solved using proportions, and the rest of the problems on here follow a similar idea. Okay? Make sure that you're doing part divided by whole for the first section with percentages, setting up the triangles, having them in the correct places, bottoms with bottoms and sides with sides, and so on. And that you're setting up the proportions properly in number 3. Problems like number 3, the word problems toward the end. And problem number 3, by the way, is called indirect measurement, because I would hate to have to just climb up and measure the tree at 16 feet. But I can use shadows in order to figure that out. That's a real world situation. And if you're interested, you can ask me about it because I have actually done this. So real world situation that maybe you'll use someday, and maybe not, but at least you can use it in math class and finish this worksheet. If you have any questions, make sure you ask them, please.